In this video, I am going to discuss about a very interesting topic which is most neglected but most important aspect in any mineral exploration as well as sampling program. Of course, most of the industry of always maintained properly, but at certain cases in government organization, these aspects are often highly neglected. So, yes, quality assurance and quality control. This is also very significant while sampling in any mineral exploration. So, quality assurance deals with prevention of problems and QC aims to detect these in time. Yes, timely detection of any error is of ultimate importance. In case of very low grade and the extremely irregular mineralization, for example gold mineralization, because we are getting gold in ppb level in general, and whenever it is getting enriched up to ppm level, that itself is economic. But what about the control? It is mostly found in particular specified terrain with proper metallogenic epochs and metallogenic provinces with lot of uncertainty factors. This is encountered at small micro cracks, veinlets. There, sampling needs to be taken care of with most significantly. Okay, so when QAQC is most significant, that is of course for low grade and highly irregular type deposits. Of course, in case of any regular stratiform, strata bound like coal, graphite, for these kinds of bulk commodities, then also QAQC protocol should be followed. But impact of QAQC negligence is most likely ultimately results in failure of the program, especially during highly irregular mineralization like gold. So let's start. See, this is the all type of error. I have just kept it at a glance. So sampling error are of different types and it can be introduced at various stages of exploration. So some are normal random errors, okay, that give precision but inaccuracy, like fundamental error, grouping and segregation error, and others are in our hand, that is incorrect sampling error, ISE. So those I will be more focusing on incorrect sampling error like delimitation, extraction, weighing, preparation and analytical errors. Okay, but in brief I will also touch these acronyms FSE, GSE, IDE. So FSE and GSE, these are grouping and segregation and fundamental errors. These are not directly in our hand. Of course, it should be minimized. So, results from grade heterogeneity of the broken lot of all sampling errors. FSE does not cancel out and remain even if sample operation is correct. So, experience shows that the total nugget effect in variographic modeling can also be artificially high because sample masses are not optimal. Similarly, that GSE, grouping and segregation error, relates to the error due to combination of grouping segregation of rock fragments in the lot. Once rock is broken, there will be segregation of particles at all scales. Okay, so leave this. Now we will directly go to the incorrect sampling errors. This is most important. So there are various stages of introduction of errors. At the beginning, suppose it results from incorrect shape of the volume, delineation of an increment of a sample, then result from incorrect extraction of sample. Okay, extraction is only correct when all fragments within the delineated volume are fully extracted. Then also weighing. Proper weighing is very important. Samples should represent consistent mass per unit. Okay. Then sample preparation error, it refers to issues during sample transport, storage. Sometimes it get mixed up, contaminated, damage, loss of alteration. Okay, these kinds of errors should be firmly adhered. Then analytical process in lab also, everywhere these kinds of samples. So fundamentally, if we now narrow down, basically there are three fundamental problems. Those are to be addressed properly. Quality control procedures are necessary to monitor accuracy, precision, contamination. Now, what is accuracy? Accuracy means correctness. Precision means repeatability. Sometimes, due to some instrumental error, that instrument can give precise result. Means every time it will be giving same result, but it will not be correct result. Okay, that is called precise result, but inaccurate. For example, if you see here in this plot, our aim is to achieve this central part. Whatever data fall in this, for example, if you see this is plus x, plus y, minus y. Okay, in this space, if this central part 0 0, for example, or you think about any value, let us see one certified reference material. For accuracy, CRM is useful. For precision or repeatability, duplicate. For contamination, blank. How? I'll discuss one by one. Okay, so contamination means the introduction of any substance to a geological sample that is not in the original in situ location of the sample. Okay, so one by one I'll discuss accuracy, precision, and contamination. First, let us start about contamination. Contamination means, suppose you have actually in your sample there is no gold, or whatever commodity that is no gold, that is called blank. Now for checking, if you knowingly analyze one blank sample in which gold is should be less than detectable limit, should be, but after getting that result you are getting some value, good value, that means of course there is some problem. How gold could come? That is due to contamination. Okay, so once blank sample will give result, that means you have to be cautious about that contamination. It might have contaminated some foreign, from some foreign source, it could have introduced. Now then accuracy means correctness. So certified reference materials are prepared by standard laboratory where particular percentage grade, that is content of that particular element of interest, is known. Now when we are analyzing, if that result is almost similar or same to that CRM actual value, known value, that will be accurate result. But if it is not close enough to the known value, it will be inaccurate. Now there is certain cases in a particular instrument. For example, we run 4 CRM, 4 known values, separate different CRM standard. In one, suppose it is already known 5%, another one suppose 15%, another one 2%, for example. Now in case of 5%, we are getting 20, where 5% is known in CRM, but after analysis we are getting 20. That means 4 times more. Where that value is 2, we are getting 8, again 4 times more. Where it is 10, again we are getting 40, 4 times more. So we are getting wrong result, inaccurate result, but consistent result. Every time we are getting 4 times, 4x. That is called precise result, but not accurate. Instrument is not functioning properly. Instrument is functioning with a particular error every time. Okay, so both the things should be of utmost important. it has to be accurate as well as precise. It is not like that we are getting precise result, that means it's okay. No. Or we are getting accurate result but not precise, that means suppose same in sample, first time we are getting result 2, then 4, again 5, or again 1, like no precise result. It is, there is no consistency, it is not reliable, that means. So for that we need to use duplicate, because duplicate means same sample is divided into two pieces, so both should have been ideally same. Duplicate means same. So once actual sample is run, there when we are getting some result, duplicate sample also should give same result. That means if those both the things are giving same result, it is precise data. And accuracy means already it is known, and we have to check, cross check that value. If it is coming closer to the known value, it is accurate. If it is repeatedly giving same value, means because duplicate means both the samples are ideally same, so both the duplicate, original and its duplicate, should give same result. If duplicate giving separate result than its original piece, that means the result is not precise. So I hope you understood now importance of accuracy, precision and contamination. Always remember three things. For accuracy, certified reference material CRM. For precision, duplicate. And for contamination, blank are used. Okay. Now there is further subdivision. Now some basics need to be understood now. During grade control, QA/QC should include field duplicate and certified reference material submission, and this we need to mix with that our sample. Whatever sample are sent to the lab, we should not disclose. Within that, known CRM should be inserted so that bias can be minimized. Any type of prejudice must be avoided. Whatever data finally will come along with that blank CRM, all has been mixed, and sample sender already knows the position in the sample slip, sample list, number of samples within that, which number particular identifiable serial number is blank, which one is CRM. Then they need to check. If it is coming well, that means that instrument, all the data is fine, it is acceptable, accurate as well as precise as well as non-contaminated. So laboratory QA/QC shall include internal CRMs, pulp duplicates, umpire sample submission, pulp screen test, contamination tests, etc. In particular, duplicate field samples provide a measure of variability of the entire sampling and analysis process. So best practice QS/QC is a very comprehensive framework. Okay. So now you understand how that duplicate, blanks, these are further subdivided. Duplicates may be of different size category, and with different stages of sampling, different type of duplicate can be made. I'll tell in detail further. First, let us now discuss briefly about geological standard, that is certified reference material, mostly made as standard. So a composite of naturally occurring geological material for which an accepted mean and accepted error on the mean has been predefined. It is known. So the standard is used to monitor the accuracy. Certified reference material of known value and certified reference material of zero value are called as standard and blank respectively. Samples, so this standard and blank samples are inserted within the routine samples at industry accepted intervals, in general 1 in 20. So within, if you are having say 20 samples, so one blank, one duplicate you can add. Okay. and then dispatched to the laboratory for quality control purpose. These standard and black samples can be inserted at a start, end, and every 10th or 20th position. It depends, okay, in the sample string. It is desirable to change the sequence of insertion of blanks and standards from time to time for quality assurance. Laboratory personnel should not know, because there may be some bias. If they know blank, they will be forcefully making it to zero. Once blank sample gives some value, data should guide us, we should not guide data. And that is the problem with most of the government agency. Often they neglect these kinds of standard protocol. So most of the certified reference materials, of course, in analytical lab they can use, but it should understand that awareness must be spread across the all geological fraternity, that whoever doing field work, their QAQC program starts from their end only. They must send proper QAQC sample along with that sample slip. So that awareness is required in individual level in field workers. Amongst that field workers, whoever doing lithologging, lithocoding, core sampling or graph sampling, it starts from their end. So this may be purchased from a number of sources, including like this, whatever the list. Apart from that, it is not restricted up to this. There are so many others where I have just kept a few. These are the standard certified reference materials. And blank, if it is your budget does not permit, you can give known, using your geological common sense, you can introduce blank. For example, if you are doing some graphite exploration, graphite, occurs as I have uploaded earlier also, different aspects, geological aspects of graphite. So in case of graphite, what should be the blank? There comes your knowledge. Graphite, in which raw graphite you cannot even expect, like igneous rock, for example, typical granite or quartz vein, simple quartz means SiO2. There is no question of carbon, graphitic carbon, okay. But there are, you must be aware about that if it is total sulfur is required, because often in graphite industry, along with TGC, total graphitic carbon, sulfur content is also required. So in that case, you must be aware to choose blank, because such that way you will have to choose that pyrite should not be there in that. For example, if you have some vein quartz, within that there is a possibility of getting hydrothermal pyrites, then it cannot be acted as blank. Of course, although graphitic carbon is absent, but there is likelihood of getting sulfite. So accordingly, you'll have to choose judiciously the blank, and CRM you need to purchase from standard. There are several vendors. Now I'll give further detail about field duplicates. As I told, the QAQC protocol, QAQC things are starts from just field works, field level only. So when drilling is completed, while sampling, you need to split the drill core or RC drilling chips. From the sampling interval properly, you can, yeah, as per your protocol, your program, you need to choose. And these splits are bagged separately with separate sample numbers, so as to be blind to the sample preparation laboratory. If it is duplicate, same number you are giving, laboratory personnel will be automatically understanding these are same samples, so result must be same. No. So for that purpose, purposefully you will be giving separate number. Although you in your personal database you have all records, because these two words, although separate number, but these are same sample, because these are called duplicate. But lab, you should not disclose these details to the lab. These are standard protocol. The use of field duplicates is actually, it contains all levels of errors: core or RC cutting, splitting, sample size reduction, preparation lab, subsampling, pulp. Different type errors can be checked. Okay. So the duplicates are used to calculate field preparation and analytical precision. So at the beginning, if you split the course, one keep with you, and from that another piece you have to further divide into two. That means it become quarter. So out of this quarter, do two pieces with separate name, separate identity, ID, you are sending that to the lab. When that result will come, you need to check whether these are coming same or not. If not same or similar, that means there is a error. It has to be, there are certain, of course, exact same cannot be possible, but to a certain degree of certainty, two standard deviation must be there. So accordingly, after that, duplicates can be made when you are crossing the samples. That cross samples also can be divided into two. Okay, so like that, different stages you need to make duplicates. So there are two standard terminology: coarse duplicate and pulp duplicate. What are they? Coarse duplicate refers to duplicate sample collected from the same batch of material after it has undergone coarse crushing or reduction. It is crushing related, after crushing, before pulverization. Okay, but pulp duplicate, when it is made, pulp duplicates refer to second sample collected from pulverized sample after crushing. Okay, so pulp duplicate means pulp. From the terminology itself you can understand this total fine powder is being divided into two, usually below 75 or 100 microns, but for coarse duplicate it is more than mostly 100 or 75 microns. Okay, most of the coarse duplicate are more than 100 micron, and pulp duplicate are less than 100 or 75 micron. That is the difference. Coarse duplicate means coarse size, pulp duplicate means finer size. Okay, so coarse duplicates are used to assess sampling precision. Precision means repeatability. At the beginning itself I told, both any duplicate are used to check precision. They help to evaluate how consistent the sampling process is when dealing with the larger size material. And pulp duplicate purpose, it is also multiple purposefully used: batch re-examination, laboratory purpose, performance assessment. Okay, so relative difference between duplicate pairs in case of coarse duplicate are considered satisfactory if at least 90% of the pair have relative difference of less than 20%. But for pulp duplicate, the result is considered satisfactory if at least 90% of the pair falls below the 10% relative difference mark. Because as you are homogenizing, keep on homogenizing, uh, knowingly, purposefully you are sending more better data. Pulp duplicate means more homogenized data. So you can expect more accurate result. So once you will get that result, for example, here I have shown it. Say original percent zinc, and this is duplicate half core zinc percent. You plot this. You should fall. You should, both the samples should be given same value or similar value. After plotting, you can check it is regress by regression or by the standard line fixation. You can understand all the samples, both the duplicate as well as corresponding original core, should give same result. So it will be following on line, 40-degree angle line. Okay, and whatever result fall away from this line, these are outliers, this is wrong. So these things are to be rejected. You cannot consider this result. Okay, if the samples are analyzed at different laboratories, there is likely to be some bias due to different laboratory personnel, that is analysts or analytical procedures. Same result can be acquired by different analytical procedures like AAS, volumetric XRD. XRD can give some result. Same data with AAS also give some result of that same particular element. So those two results can be checked like this also. Hmm? Different factors are there. A set of same samples should be analyzed at all encountered concerned laboratories as well as referee laboratories of international repute. So then statistically this can be even tested. Just for example, t-tests. If you know, I have already discussed about importance of t-tests. Okay, in statistics portion, I'll tag this at the end. The data error between paired sets can be analyzed by various statistical tests. Simplest one is a scatter plot of paired data. Scatter diagram will easily identify the presence of extreme erratic high or low values. For example, here if you see, okay, identified isolated, and their authenticity is investigated along the probable source of errors. The samples can be verified and rejected if they do not satisfy or fit into the geological conditions. The filtered dataset will be suitable for QAQC analysis. The plot must show remarkable degree of correlation at high degree of confidence. Okay, and if check assay results are lying in the acceptable range of standard deviation within less than 5% variation, some from the mean value at 95% level of significance, then assay results are captured in the main assay database. Okay, इसमें मैं अब ज़्यादा detail, I am not going into much detail. Statistical concepts are involved. Now let us simply discuss about blank. Sample of uncrushed rock or drill core that is known to contain a very low or non-detectable concentration of the element being sought. The blank is used to monitor contamination. It is just, I am again repeating knowingly, purposefully. There is a important round robin concept. The analysis of a newly prepared geological standard done in replicate by a number of labs. CRM often sometimes are not available. In that case, several times from several standard laboratory you can analyze the same sample, and once you will be getting same result, that same result you can assign as that CRM for that particular sample. This is called secondary CRM. Okay, so this reliable value with reliable standard deviation, you can fix it and you can assign it as secondary standard. That is called a procedure round robin. Okay, the purpose of which is to calculate the accepted mean and standard deviation. At least 60 analysis using a minimum of 5 labs are recommended to prepare these kinds of CRM. Then finally, regulatory compliance is very much essential. Whatever I told, those things should be complied properly. Industrial standards, fundamental QAQC complies with environmental and safety regulations along with ethical business practice, ensure responsibility and responsible mineral exploration. So QC program monitoring mainly indicates field duplicates, which are further subdivided into cores, pulp. Okay, then different CRM standards, field blanks, and laboratory duplicates as well. In all the stages of exploration, QAQC protocol must be strictly adhered, must be properly followed, which is often I found personally, even I also could not understand due to lack of awareness during my government responsibility when I was in field. Yeah, that kind of training was not that much given because it is because of lack of awareness, where often, not every time, but sometimes the government organization ground level work are lagging. But in laboratory, of course, they are precisely following these things. But in field file sampling, these kinds of negligence I have come across. So in the case of drill core sampling, usually one half of the core is processed for analysis. Again, I am telling, used for reservoir research estimation without confirming the grade representation of other half, which is the mirror image in the system. And the second half of the core should be processed, analyzed for certain length of mineralization, then statistically verified and accepted or modified, and if and when required, it can be rejected. There can be an inherent human and process error in a laboratory while analyzing the sample. So the duplicate sample of known value are inserted at an industry accepted protocol of 10th or 20th position, as I have already mentioned. So after inserting in the sample run and analysis, after getting that analysis throughout the explosion phase at the same laboratory without disclosing the identity of the sample, the result of two sets can be further tested statistically for mean variance, scatter plot, correlation coefficient, if required, pair t-test, f-test, pool t, before final acceptance, modification, and rejection. So for that reason, statistical understanding is also important. Explosion is like hodgepodge. Everything should be understood. You should not claim you are a good sedimentologist or structural geologist. You are a geologist or exploration geologist. That means all the things you should be aware of. Finally, just if you see, these are the action: field duplicates, sample quality index, course reject duplicates, pulp duplicates, certified reference materials, blanks, pulp quality, barren, barren flash, umpire say, laboratory audit, QAQC review. There is a rate. Field duplicates must be inserted 1 in 20 samples. Sample quality index, all sample quality index, sample quality must be thoroughly checked and mentioned, documented. Course reject duplicate also 1 in 20, pulp also 1 in 20, certified reference material is also, these are all in 1 in 20. Each after 20 sample once you have to introduce. This in this interval you keep on adding. Okay, and this is the important key performance indicator. For example, CRM, for example, if you are having known value, so after having that result, it should not be much more different. Difference limit must be within 90% plus minus 10 to 25% HRD. Hard value means HRD full form is half absolute relative difference. For example, two samples A and B, their known value is known, already known. Now we are getting some result. So the difference should be, suppose lab result is B and CRM value, already known value, is A. So HRD means A minus B divided by A plus B by 2 into 0.5. That means half. Okay. So half absolute relative difference. So that another terminology is relative standard deviation, RSD. That is standard deviation divided by mean into 100%. So generally, hard and RSB are almost similar criteria. Usually root 2 divided by 2 into RSB is equal to hard, HRD. So for example, here if you see, plus minus 10 hard means plus minus 13 RSB, because root 2 by 2. Okay, root 2 by 2 into hard value means RSB. Sorry, root 2 by 2 into RSB equal to hard value. So like that, within this limit we can accept. More than that we cannot accept. So 90% plus minus 10 or 25%. This is the acceptable range. So if it is value is 100, a known value is 100, we cannot tolerate 89 even. It should be within 90 to 95 and more, like this. Similarly, course reject, then pulp duplicates, everywhere these kinds of things are fixed. Certified reference material, again you see, 2 standard deviation is safe zone, 2 to 3 standard deviation when it is coming no, from that mean value, if we are getting a result that is deviated up to 2 or 3 standard deviation, that means that is a warning sign. Then we need to reassay at least 25% of the samples. And if it is more than 3 standard deviation, then total samples must be reassayed. Because in general already it is mentioned, for certified reference material, known value that is mean value of the CRM plus minus 2 standard deviation is acceptable. That is simple as that. When more than 2, we need to think about how much. 2 to 3 if it is, then 25% reassay, and if more than 3 standard deviation, you cannot tolerate. You will have to totally again reassess all the samples. So that's it for now. This is a brief overview. This is the detail. If you need for details, I have jotted down. This you can just pause it and you can go through. Thank you.